For more than 5,000 years, the world has believed in one story. That Sumeria and Huaxia were two parallel worlds, with no intersection, no knowledge of each other. That the symbols etched into Mesopotamian clay tablets and the markings carved onto Yellow River oracle bones developed in complete isolation. That story was repeated enough times to become a truth requiring no proof. There was no confirming evidence, only the story. But DNA does not listen to stories. DNA only reads the truth. When scientists first placed the genomes of ancient Sumerians beside those of the Huaxia people, the results that appeared on the screen shook the field of anthropology. Not because they confirmed what people suspected, but because they revealed a picture more complex, stranger, and more fascinating than any hypothesis ever proposed. This is what they found. And this is the chapter of history no school ever taught you. To understand why the DNA results caused such a shock, we need to go back to the year 1894, when a French scholar named Albert Tarim de la Couperie published a thesis that shook the entire academic world, that Kangxi, the legendary creator of writing worshipped by the Chinese for thousands of years, was in fact a Sumerian leader named Dungi. Around 2300 BC, he supposedly led a massive migration from Mesopotamia, crossing the deserts of Central Asia to lay the first bricks of Huaxia civilization. The evidence La Couperie presented was not without foundation. Sumerian pictographs and Shang oracle bone script shared the same ideographic thinking. Both civilizations divided calendars according to constellations. Mesopotamia used a base 60 numerical system, while China developed the complex heavenly stems and earthly branches system. The Epic of Gilgamesh told of a great flood that destroyed the world, while on the other side of the continent, the legend of Yu the Great controlling the floods told a story so remarkably similar it could not be ignored. Coincidence or evidence? That was the question archaeologists struggled with for more than a century without finding a satisfactory answer. Chinese academia completely rejected the Western origin theory, viewing it as a product of colonial thinking intended to diminish the independence of Eastern civilization. And their argument was not without merit, because traditional archaeology searched everywhere, without finding any transitional material evidence. No Mesopotamian-style fired bricks appearing along the Yellow River, no oracle bone fragments discovered in Babylon, no confirmed trade routes, nothing except cultural similarities interpreted by each side in completely opposite ways. The debate dragged on for 130 years without resolution, until an entirely different tool appeared, a tool that did not read hypotheses, was not influenced by political bias, and could not be interpreted in two directions at the same time. Pottery fragments could be copied, symbols could be misunderstood, but genetic code could not. And that was when ancient genetics entered the debate, not as another side in the conflict, but as the only referee capable of delivering a final verdict. Before placing the two civilizations on the genetic scale, science first had to answer a fundamental question, a question that seemed simple but had left generations of researchers helpless for decades. Who exactly were the Sumerians, and what biological signatures did their genome carry? This was not a philosophical question, it was a technical one, and to answer it, scientists had to confront an enemy absent from every laboratory: time. The land of Mesopotamia today lies within the territory of Iraq, and Iraq is not a place where DNA wants to survive. The extreme hot and humid climate, highly alkaline soil layers, and violent temperature fluctuations between day and night all combine to create an almost perfect environment for destroying the bond structures of ancient DNA within only a few centuries, let alone thousands of years. When scientists excavated skeletons from Sumerian cemeteries, what they found was not a biological archive, but ruins. The collagen had decayed, the calcium had dissolved. What remained was only the shape of bone, no longer real bone anymore. For many years, the scientific community almost accepted that Sumerian DNA had been lost forever, that the people who built humanity's first city-states, who invented writing and the wheel, would forever remain a biological mystery beyond decoding. But science does not surrender so easily. Instead of searching for DNA in obvious places, geneticists began looking where few had thought to search. Two locations in the human body that nature had accidentally designed as biological safes: thick tooth enamel and the petrous bone buried deep inside the skull near the inner ear. Tooth enamel is the hardest material in the human body, compressed so densely that bacteria and moisture can barely penetrate it. The petrous bone is even more durable. Its bone density is so high that even under the harshest conditions, the nucleotide chains inside can survive for thousands of years without being completely destroyed. These were tiny bone fragments, difficult to access, and for decades entirely overlooked in excavations because no one believed they possessed any special value. But with modern ultratrace technology, they became the most precious material an ancient geneticist could find. Scientists began collecting these petrous bone samples from ancient royal cemeteries at Ur and Kish, two of the largest and oldest city-states of Sumerian civilization, where kings and priests were buried alongside hundreds of servants and enormous treasures. And when the first data sequences were completely decoded, An unexpectedly sharp and consistent genetic picture appeared on the screen. For the first time in history, science could look directly into the genome of the people who built humanity's first civilization. The first results came from the paternal line, the Y chromosome passed from father to son across generations, the most direct biological marker of evolutionary lineage through males. And what the data revealed was the overwhelming dominance of two haplogroups. Haplogroup J, particularly the J1 and J2 branches, along with haplogroup G2. In the global map of population genetics, these were not random numbers. These were biological signatures associated with the pioneering farming communities that ignited the Neolithic Revolution in the Fertile Crescent more than 10,000 years ago, the first people to domesticate wheat, barley, and livestock, laying the foundation for the entire production economy of the modern world. In other words, the Sumerians were not outsiders. They did not come from some distant place, nor were they the product of a mysterious migration from another civilization. They were native children of that very land, direct descendants of the first farmers who had settled in the Near East thousands of years before the rise of the Sumerian city-states. That was the first answer, and it was enough to overturn some old theories. But the paternal line was only half the picture. When scientists turned to mitochondrial DNA analysis, inherited through the maternal line, passed intact from mother to child through every generation without recombination, they found the overwhelming presence of haplogroups T, U, and K, biological markers characteristic of prehistoric Middle Eastern populations and Anatolian peoples in present-day Turkey. Both paternal and maternal lines pointed in the same direction. The Sumerians were a genetically coherent population with deep roots in the Near East itself, showing no evidence of major admixture from distant populations. To place all this data into a broader picture, researchers fed the entire dataset into principal component analysis, or PCA, an algorithmic tool that allows visual comparison of the genetic position of any population against all surviving human populations on Earth today. And the PCA results clarified something many had not expected. The ancient Sumerians did not disappear. Their empire fell to the Akkadians, then the Babylonians, then the Persians, but their bloodline did not vanish with them. On the PCA chart, the ancient Sumerian genome clustered closest to the marsh Arabs living today in the wetlands of southern Iraq, followed by the Assyrians and the Mandaeans, minority communities that had maintained isolated lifestyles and little intermarriage with outsiders for thousands of years. And it was precisely that isolation that preserved the bloodline of the people who built humanity's first civilization. All of this evidence pointed to one conclusion alone. The Sumerians belonged entirely to the broader West Eurasian population. The Western Eurasian peoples carrying genetic characteristics specific to the Mediterranean and Near Eastern regions, a complete and coherent genetic block whose evolutionary history had diverged entirely from the rest of the world tens of thousands of years ago. This was the frame of reference, the clear, certain, indisputable starting point. And only after that frame of reference had been established could science take the next step, placing it beside the East Eurasian populations on the other side of the continent and letting the two datasets speak to each other for themselves. On the other side of the continent, tens of thousands of miles away from Mesopotamia, an entirely different evolutionary story was unfolding. Not a story about people coming from elsewhere, not a story about waves of migration or biological conquest, but the story of a genetic block that matured in silence, shaped itself over tens of thousands of years on the very land where it was born, and created one of the greatest and most enduring civilizations humanity has ever known. To reconstruct the genetic portrait of the ancient Huaxia people, scientists did not merely excavate one site or analyze one population. They carried large-scale genome decoding campaigns across the core regions of East Asian civilization, collecting a DNA data from the bones and teeth of inhabitants belonging to cultures spanning thousands of years of history. The Yangshao culture with its characteristic painted pottery along the Yellow River Basin, the Longshan culture with its astonishingly refined black pottery craftsmanship, and the Hemudu culture associated with the earliest domesticated rice in the lower Yangtze River region. People who had lived, farmed, and died on that land thousands of years before any dynasty was ever recorded in historical texts. And when the nucleotide sequences from those ancient skeletons were decoded under the light of modern technology, the results appeared with astonishing consistency, a signal so clear, coherent, and unmistakable across the entire span of Eastern civilization's history. At the center of that genetic picture was haplogroup O, the haplogroup overwhelmingly dominating the paternal lineage of the Huaxia people, with the O1, O2, and O3 subclades appearing at overwhelming frequencies, accounting for 70 to 80% of the male line genetic structure in all analyzed skeletal samples, from the Neolithic through the Bronze Age, and continuing uninterrupted all the way to modern Han Chinese today. Haplogroup O was not a random number on the global genetic map. It was the biological signature of farming communities that domesticated wheat and barley in the north and rice in the south, people who had been tied to the land of East Asia for tens of thousands of years, and who built the entire economic and social foundation of Asia's greatest civilization themselves, without requiring any biological borrowing from outside populations. To understand why this mattered so profoundly in the genetic dialogue with the Sumerians, one must understand a foundational concept established by science: the split between the two largest population groups on the Eurasian continent, an event that occurred between 40,000 and 50,000 years ago, and left biological consequences that persist to this very day. When the first waves of modern Homo sapiens left Africa and entered Eurasia, they did not move in a single direction. They split in two, and those two branches never truly reunited in any biologically significant way. The western branch crossed through the Middle East, spread into Anatolia and Europe, gradually forming the West Eurasian bloc of which the Sumerians were a typical representative. The eastern branch crossed the corridors of South Asia, moved northward and into East Asia, where it became completely isolated by a system of natural barriers unmatched almost anywhere else on Earth. The Himalayas, the highest mountain range in the world, the Tibetan Plateau with an average elevation near 5,000 meters, and the endless arid deserts of Central Asia. During nearly 50,000 years of isolation, the East Eurasian genetic bloc evolved along its own trajectory, accumulating characteristic mutations adapted to East Asian climates, creating a biological boundary so deep and distinct that no analytical tool could mistake an East Eurasian genome for a West Eurasian one. They differed not merely at a few mutation points, but across their entire genetic architecture, their evolutionary histories, and the natural selection pressures that shaped every nucleotide sequence over 50 millennia without intersection. But what truly shocked researchers in the Huaxia DNA data was not merely the haplogroup structure. It was the genetic continuity spanning the entire length of history, a persistence so extraordinary that many scientists reportedly rechecked the results multiple times before believing what they were seeing. When researchers sampled DNA from the bones of Shang dynasty nobles, the people who carved the earliest oracle bone inscriptions onto turtle shells more than 3,000 years ago, and compared them with the genetic structure of modern Han Chinese today, the match was nearly perfect. There was no sign of massive population replacement waves, no evidence of biological invasions from the West, no interruption in the continuous genetic chain stretching from the Neolithic farmers along the Yellow River to the more than 1 billion Han Chinese living on Earth today. The Huaxia people did not require a foreign king to guide them, nor a migration wave from Babylon or Mesopotamia to give birth to their civilization. They were the pure and resilient product of East soil itself, a genetic bloc that shaped itself, developed itself, and created one of the longest and most enduring civilizational stories in all of human history. And now, with both genetic pictures reconstructed in full clarity, the West Eurasian profile of the Sumerians with haplogroups J and G2, and the East Eurasian profile of the Huaxia people dominated overwhelmingly by haplogroup O. Science finally possessed enough data to take the next step, the step that more than 130 years of academic debate had failed to achieve: to place the two datasets side by side, to let them speak to each other, and to listen to what DNA, the only thing incapable of lying, would decide about the question that had haunted science for more than a century. When those two massive genetic datasets were finally fed into computer systems and forced into direct dialogue for the first time in history, no one in the laboratory spoke to each other. They simply stared at the screen and waited, because everyone understood that the results about to appear would not merely answer an academic question, but would decide the fate of a debate that had lasted more than 130 years without any material evidence capable of resolving it. The tool they used was genetic distance, a mathematical metric designed to determine precisely the degree of biological separation between populations based on mutation frequencies across millions of single nucleotide polymorphisms throughout the genome, a number that could not be interpreted in two directions, could not be influenced by political arguments, and did not care about the expectations of anyone standing in the laboratory that day. And when the principal component analysis chart displayed the visual results on the screen, what they saw ended the debate in a way no one had predicted, not with an ambiguous answer requiring more data for confirmation, but with a verdict so clear it was almost cold. The genomes of the ancient Sumerians and the Huaxia people occupied completely opposite poles on the map of human genetics. The distance between them, not the distance between two branches of the same family tree, but the distance between two biological worlds that had not intersected for nearly 50,000 years. Two genetic blocks evolving in parallel in complete isolation and leaving signatures so distinct that no algorithm could find a shared genetic thread large enough to suggest a direct ancestral relationship. There was no trace of widespread admixture, no biological migration corridor leaving a detectable imprint in the genomes of either population, and there existed no father-child relationship or common origin between the inhabitants of Mesopotamia and prehistoric Chinese populations in the sense claimed for more than a century by Le Couperus. Western origin theory. The laboratory verdict officially pronounced the complete death of that hypothesis. King Dungi, the migrating caravans from Babylon crossing the deserts of Central Asia to give birth to Huaxia civilization, all of it was merely a product of imagination constructed from superficial cultural similarities, lacking any biological foundation to stand upon. But at the exact moment the scientific community believed everything had finally been settled, the genetic verdict erected an even larger wall of paradox than the question it had just answered. If these two civilizations had developed in complete biological isolation, if their bloodlines had never intersected in any meaningful sense, then why were the cultural similarities between Sumeria and Huaxia so deep and so consistent, both developing pictographic writing systems to record the world around them, both observing the night sky and dividing calendars according to constellations, both constructing sophisticated mathematical systems that Mesopotamia called Base 60, while China called the heavenly stems and earthly branches system, and both preserving memories of a world-destroying flood in mythological stories whose similarities had forced scholars to ask questions for centuries. That question did not disappear simply because DNA had rejected a blood relationship. It became sharper, more uncomfortable, and demanded an entirely different kind of answer. And the answer science offered was not a new hypothesis of migration or secret contact, but a more fundamental concept, a realization about the nature of human intelligence itself that genetics had accidentally exposed while attempting to resolve a historical debate. Convergent cultural evolution. The brains of Homo sapiens, whether born in Mesopotamia or along the Yellow River, were equipped with the same biological structure, the same methods of processing information, and the same logical tendencies when confronting similar survival problems. When two genetically distinct human populations both underwent the transition from hunter-gatherer societies to settled agriculture, both had to manage increasingly large communities, and both faced the unpredictable floods of great rivers, the Tigris and Euphrates in the west, the Yellow River in the east. They would naturally arrive at similar solutions not because they learned from one another, but because the human brain possesses only a limited number of effective ways to solve the same problem. The Sumerians looked up at the night sky and realized that the cyclical movement of the stars could be used to divide time and predict agricultural seasons. And the Huaxia people on the other side of the continent looked up at the same night sky and reached the same conclusion, not because someone had taught them, but because it was the only effective way to farm under unpredictable climatic conditions. The similarity between the two civilizations was not evidence of shared blood. It was evidence of a shared brain, and that was something greater than any genetic connection. But just as the scientific community prepared to close the case with a neat conclusion about complete isolation and convergent cultural evolution, artificial intelligence algorithms scanning deep into the microscopic genetic segments of ancient Huaxia populations suddenly detected an anomalous signal, tiny, deeply hidden, and completely absent from any scenario science had prepared for. And that signal would open the door to the second shock. A shock that would not overturn the verdict of isolation, but would complicate it in a way no one in that laboratory could possibly have anticipated. But science was not finished. Just as the verdict of complete isolation seemed ready to close every remaining question, the supercomputer algorithms, scanning deeply into the microscopic genetic segments of ancient Huaxia populations, suddenly stopped a signal that no one in the laboratory had prepared themselves to see. Within the genomes of prehistoric inhabitants of the Yellow River Basin, hidden beneath the overwhelmingly dominant haplogroup O layer, there was something that did not belong to East Asia, a tiny, scattered signal, yet consistent enough that it could not be explained away as statistical noise, accounting for between 1 and 3% of the total genetic structure. And when the comparison algorithms completed their analysis, its origin pointed in only one direction: ancient West Asia, the geographical region encompassing the very Mesopotamian valley of the Sumerians. The entire laboratory fell silent, not because the number was large. 1 to 3% was extremely small, nowhere near enough to suggest a migration or a wave of population replacement. But it was there, and the question raised by its existence was far greater than the number itself. By what mechanism, and through what journey, could fragments of DNA from the distant Near East have crossed tens of thousands of miles of desert, crossed eternal snow-covered mountain ranges, and implanted themselves into the bloodlines of people living in the Central Plains, at a time when the Silk Road was still more than 1,000 years away from even existing as an idea? This was not a question traditional archaeology could answer. There were no recorded trade routes, no historical documents confirming contact, and no direct material evidence linking the two ends of the continent at that time. To search for answers, population geneticists were forced to turn toward the figures most often ignored by official history. Not kings building city-states, not priests carving symbols into clay, but nomadic warriors of the vast Eurasian steppe, People who left behind no libraries or monumental architecture, but left behind something more enduring than all of them: DNA inside the bones of their descendants. Science determined that around 4,000 years ago, nomadic populations belonging to the Yamnaya and Afanasyevo cultures, the first peoples to domesticate war horses and master bronze casting on the steppe plains of what is now Russia and Ukraine, undertook southward expeditions, came into contact and intermixed it with long-established settled populations on the northern fringes of the Middle East. People who were themselves close genetic relatives of the ancient Sumerian inhabitants, and after absorbing that West Asian bloodline into their veins, the descendants of those steppe warriors continued their journey eastward, their horses crossing the Altai Mountains, moving along the oasis routes of the Huaxia corridor until reaching the lands of Gansu on the frontier of ancient China, and there, through interethnic marriages in those border regions, fragments of West Asian DNA quietly seeped into the Huaxia genetic block without leaving any visible trace on the surface of recorded history. The clearest material and biological evidence for this silent genetic corridor came from a place no one expected: the Tarim Basin in Xinjiang, where the cold, dry sands of the desert preserved mummies dating back 3,000 to 4,000 years in astonishing condition, with hair still retaining its color, linen fabrics still preserving their woven patterns, and faces still distinct enough to make archaeologists stop and stare. Because those faces were neither purely East Asian nor purely West Asian, they were something in between, vivid and mysterious, as though nature itself had deliberately placed a question mark in the middle of the continent and waited for science to become sophisticated enough to read it. When the DNA of the Tarim mummies was decoded, the answer emerged with undeniable clarity. They were a perfect mixture of local East Asian genetic structure and ancient West Asian genetic fragments originating from the Near East, precisely the kind of genetic signal the algorithms had detected hidden deep inside the genomes of ancient Huaxia populations, and precisely the evidence science needed to reconstruct the mechanism of that invisible genetic corridor. The people of the Tarim Basin and the nomadic tribes along the Huaxia corridor were not merely biological intermediaries. They were transmitters of civilization in the fullest sense of the word, carrying not only fragments of West Asian DNA in their bloodstreams but also bronze casting technology, two-wheeled chariot designs, and the techniques for cultivating wheat and barley. The core technological achievements that Shang and Zhou society absorbed and integrated into their civilization without requiring any invasion or population replacement. And this is what the entire genetic comparison ultimately revealed. Not a simple answer, but a more complex and honest picture of how civilizations truly develop. Huaxia civilization was entirely endogenous in human terms, its genetic backbone neither replaced nor interrupted. Yet it was never truly isolated. Fragments of West Asian DNA seeped through the steppe corridors. Bronze Age technologies spread beneath the hooves of nomadic warriors, and the result was a civilization confident enough to absorb the world's finest achievements without losing its own identity. Looking deeply into the map of human genetics after everything science has discovered, we do not see walls dividing races or impenetrable biological borders. We see an intricate network of silent flows, invisible corridors, meetings never recorded in historical texts but preserved in every cell of the people who lived and died upon the steppe thousands of years ago. And DNA, the one thing incapable of lying, incapable of being bribed by political bias, recorded all of it in silence, waiting for the day science became sophisticated enough to read what history had, intentionally or unintentionally, overlooked. If this story makes you reconsider what you thought you knew about human history, share it with someone you feel should hear it too. And leave in the comments a question you want science to answer next, because every one of those questions is a door that DNA is waiting to open.